Now, one thing you're also expected to know how to do is to determine the appropriate sample size to achieve a certain confidence level. Now, basically, we're going to take the formula off the math chart and solve it for n. Now, this isn't exactly the formula on the math chart. This is. So it's your statistic, which is like your critical value. Oh, sorry. Well, this is the margin of error part right here that I'm looking at, which is your critical value times your standard deviation for the statistic. Since we're dealing with a proportion, that I got this formula from the other side of the math chart, that's sigma p hat. Now, we can rearrange this margin of error formula to create a shortcut to determine the desired sample size. And note that this is not on your math chart. So if you want to use it, you need to memorize it. Basically, I'm starting with what I had before on the previous slide. And then I'm going to square both sides. And then basically, I'm going to cross multiply. I put a 1 underneath here and then solve for n, which ends up giving me this formula. So you might find this handy. You might want to go ahead and write it on your 3x5 card for when you're studying, when you need to determine sample size. But again, remember, it's not on your math chart. If you intend to use this on the AP test, you must memorize it. Okay, in this example, we're looking at a new medication that finds that 27% of 53 subjects reported improvement. Now, we want to go ahead and do a larger sample where we can have a plus or minus 5% with a 98% confidence level. So how much larger does that sample need to be? First of all, we know p hat is 0.27. That's our initial value. And we want a 98% confidence. So that would be 1 minus 0.98, which would be 0.02. We divide by 2, so take inverse norm of 0.01. Remember, since it's lower than 0.5, we're going to get a negative here. But we're going to go ahead and use a positive later. Now, here's our margin of error formula. Margin of error is your critical value, your critical value times your standard deviation for your statistic. And I'm going to put the 0.05 in for the margin of error. This value, the positive, I'm going to put in for 2.32. And I'm going to go ahead and just solve it for the standard error. So my standard error should be 0.0215. Now I'm going to go ahead and use the standard error formula, substituting this 0.0215, that 0.27, and 1 minus that, which is here. 0.0215 goes from here into the standard error, which is supposed to be p times q divided by n with the square root of all that. There's my p, there's my q. And I'm go ahead and square both sides, basically cross multiply and solve for n. So we need to run an experiment with at least 427 people receiving the new medication in order to have a margin of error plus or minus 5% with a 98% confidence level. Now, how could we know n before we're taking the first sample? Well, before gathering data, it's not that hard to determine. So margin of error, how big of a window are we okay with? Critical value, that's going to be determined by our confidence level. But what about p hat and q hat? What's the worst case scenario for this product? Well, I went ahead and did some values for p hat and q hat, which is from the formula here. The sample size is going to be proportional to the product of those two. And when is the product the largest? When they're both equal at 0.5. So worst case scenario, if you do not know the point estimate, you can use 0.5 for p hat, which is also the same for q hat. Now let's go ahead and do an example where we want a margin of error 3%. We have no idea what the proportion is, but how big a sample should we get? We're going to assume that our point estimate is 0.5 since this maximizes the product of p hat and q hat. Then we're going to use z equals 1.96 for a 95% confidence level. I didn't specify, but we're going to go ahead and use that. Margin of error formula here. Go ahead and substitute in 0.03 from here to here. 1.96 comes in there and solve for our standard error. That's the standard error I want. Go ahead and substitute it into the standard error formula with our worst case scenario for p hat and q hat. Square both sides, cross multiply and solve for n, and we get 1067.97. So We'll do what polling organizations usually do, which is a 95% confidence, and the most cautious proportion is 50%. A sample size of at least 1,068 likely voters is required. Do not use a decimal value. You always want to use an integer value because it's not like you can take that many samples.